Hi ladies, so this lesson is on sum of a geometric series or sum of a GP, and I thought I'd start with a little maths cartoon. Alright, so there's two formulas that you need to know, some more formulas that you need to memorise for this topic on series. So the sum of n terms in a geometric series, and you can use either of these two formulas depending on if the common ratio, remember R is the common ratio, if the common ratio is greater than 1, and that means an absolute value of the common ratio is greater than 1, meaning that, say, R is 2 or even negative 2, then you can use this formula, and you can use this formula here if R, or the absolute value of R is less than 1. So just say if R was half or a quarter or something like that. Okay, so I'll just go through the proof of where these formulas come from. So if we say that the sum of n terms is A plus AR squared plus all the way up to the nth term, which is AR to the n minus 1, then if we multiply everything by R, we get this equation. And if we subtract equation 2 from equation 1, we'll get this. And then the way this formula comes about is you can see that AR minus AR is 0. AR squared minus AR squared is 0. So all the terms on the diagonals, I guess you could say, would end up subtracting, and you'd be left with 0, except you'd be left over with A minus AR to the n, which is just there. And when you subtract the left-hand sides, you've got Sn minus Rsn, and if you factorise out the Sn, you're left with Sn times 1 minus R. Then we divide both sides by 1 minus R. Oh, sorry, if we factorise A outside of the right-hand side first, and then if we divide both sides by 1 minus R, you can see we get the formula up here, this one here. So where do we get the formula from on the left-hand side? Well, instead of subtracting equation 2 from equation 1, we can subtract the other way around. So going equation 2 minus equation 1. And then that'll just, then you'll just get this equation here on the left-hand side. So, using those formulas, let's apply them to some examples. So, the first example is find the sum of the first 10 terms of this series. So, you can see in number 1 that the first term A is 6. The common ratio is 24 divided by 6, or 96 divided by 24. So, the 24 divided by 6 is 4, or you can just double check to make sure this is a geometric series, not an arithmetic series, otherwise you would have to use the formula for the sum of an AP. 96 divided by 24, do a quick check, that is also 4. And n is 10, and the question is asking us to find the sum of 10 terms, so sum of 10. So just substituting into the formula, A times R to the n minus 1 all over R minus 1. And just putting that in your calculator, you will get 2,097,150. So that's the sum of the first 10 terms of that series. Example 2, find the sum of the first 9 terms of this series. So if you want, you can pause the video and see if you can have a go at that question yourself. And using the same process, A is the first term, which is 8. R is the common ratio, and you can see that the terms are alternating in sign there. Negative 24 divided by 8, which means the common ratio is going to be negative. And n is the number of terms, and it's saying we want 9 terms. So the question is asking us to find the sum of 9 terms. So we can use the formula again, just substitute in. It's A times R to the n, or R is negative 3, to the n minus 1 on r minus 1. Okay, so you can do that and you will get 39,368. Now, what's going on there on your calculator, if you were to check that, is you may get a negative 39,368. So I'm going to put absolute values there, and that's because if we go back to the formulas that you just wrote down on the first page, I'll just paste them back on this page here now. Alright, so I've got the formulas again on here from the first page, and you can see that they are very, very similar. So really, instead of remembering two formulas, you can just remember the one formula and just put absolute value signs around it like that. And then you get the same answer. Okay, let's look at some more. Number 3, evaluate the sum of this series. Now, we don't even know if that's an AP or a GP, do we? We know that the first term, A, is 6. But let's have a look and see, does it have a common difference? Plus 6, plus 6? No, it doesn't have a common difference. Does it have a common ratio? 12 divided by 6 is 2. 24 divided by 12 is 2. Yes, it does. So this is a geometric series where the common ratio is 2. And we don't know how many terms there are. We don't know what n is, but we know that the last term is 768. That's the nth term in this geometric series, which is AR to the n minus 1. So using the formula for the nth term of a GP, that's 6 times 2 to the power of n minus 1. We will solve this for n first, and then we'll be able to substitute into the sum of a GP formula. So, if 768 equals 6 times 2 to the n minus 1, then we'll divide both sides by 6. So 128 equals 2 to the power of n minus 1. And then we can either take the log of both sides and then divide through that way. Or another method is recognising that 128 is 2 to the power of 7. How convenient. Now we've got an equation, exponential equation, where the bases are the same, both bases 2, so that means the powers are the same. So we can say n minus 1 equals 7. So then plus 1 to both sides, n equals 8. So then we just need to find the sum of 8 terms, which is A outside of R to the n minus 1 on top of R minus 1. Which is 1,530. Okay, and in the very last example there, number 4, we've got sigma notation now. So we're finding the sum of the terms from starting with n equals 3 all the way up to n equals 11, where n this time represents that power in 2 to the power of n. So this is really, the sigma notation there, is the sum of the terms from 3 to 11 of 2 to the n is really 2 cubed plus 2 to the power of 4, plus 2 to the power of 5, plus all the way up to 2 to the power of 11. So that is equal to 8 plus 16 plus 32 plus all the way up to 2048. So you can see that this is a geometric series because there's no common difference, but there is a common ratio. You can see the first term is 8. The common ratio is 16 divided by 8, which is 2, or 32 divided by 16, which is also 2. And again, now how many terms do we have here actually? Well, how many terms are there from... You know there was that formula to calculate the number of terms when it's in sigma notation. It's 11 minus 3 plus 1. So that means there's going to be 9 terms. Okay, and then we can use the formula for the sum of 9 terms, where 8 is the first term. We've got 2 to the power of 9 minus 1 on 2 minus 1, just using the formula for the sum of n terms, which is 4,088. That's it.